In this video, we'll talk about what bijections are. So a function f from s to t that is both injective and surjective, in other words, if it's one-to-one and onto, is called bijective. Another way to say that is we say that there's a one-to-one correspondence between s and t. So one of the key facts is that my function is a bijection if and only if it has an inverse. And an inverse will switch the roles of the domain and the codomain. So it switches the roles of the inputs and the outputs. So for example, if f, when I plugged 2 into it, ended up equaling 6, the inverse should switch that. So f inverse of 6 should be equal to 2. One thing about notation, when I write f and then a -1 like this, it doesn't mean an exponent. So it's not 1 over f of x. This just means an inverse function. If I wanted to say 1 over f of x, we would write f of x, put a big old parentheses around the whole thing, and then put a -1. And now it means inverse. Okay, so let's do an example. Let's determine whether the function is a bijection, and if it is, find the inverse. So part A says f is a function from the reals to the positive reals, and f of x is e to the x. So we can think about the graph to help us figure out if it's injective and if it's surjective. The graph of e to the x has a horizontal asymptote at the x-axis, and then it grows like this. Okay, and if I plug 0 in for x, the y value is 1, because e to the 0 is 1. And is this injective? Does it pass the horizontal line test? Yeah, if I draw any horizontal line, it's not going to cross the graph more than once. So this passes HLT, horizontal line test. So this implies it is injective. Is it surjective? That means if I take any value in the codomain, any positive real, and I think about it as an output, do we actually achieve that output on my graph? So for this y value, this positive y value, well, I do achieve it. It's over here. This positive y value, I also achieve it. Whoops, sorry. This positive y value, I achieve it on this side. I don't need to worry about negative y values or 0 because they're not part of the codomain, which is just the positive reals. So I don't got to worry about the negative or the 0. So, well then in that case, every positive y value is achieved somewhere on the graph. So it is surjective. I'm just going to abbreviate for surjective. Because it's both injective and surjective, this means it is bijective. It is bijective. And that means it's going to have an inverse. So the inverse, f inverse, will switch the domain and codomain. So domain now is positive reals. Codomain is the reals. And if I think about the graph, it's going to switch the input and the output. So for a point like 0, 1, if I switch the input and the output, that now will go to the spot 1, 0. That now goes there. Okay, and if I keep doing that, switching the inputs and outputs for all points, we'll get that it snuggles up next to this vertical asymptote at the y-axis. And then going this way, it looks like this. And if this graph looks a bit familiar, that's good, because this is my f inverse of x is ln of x. That's our common formula for the inverse of e to the x. Okay, so nice. So what about in B? What if I change the codomain to be all of the reals? Well, there's a problem now, which is now I want to also be able to get negative y values and achieve those, but we never do. So we don't achieve negative y values. So it is not surjective. And if it's not surjective, that means it's not bijective. Not bijective. But that's weird, because doesn't e to the x have an inverse? Like, isn't it just ln of x? Like, why doesn't that work? So the problem with this is, if I think about a diagram for this, and I think about my domain of this function, which is the reals, and I think about the new codomain, which is the reals, well, if you take all the reals and you plug them in to e to the x, Well, you don't end up getting every single real number out. You only end up getting a subset of them out. You only end up getting the positive reals. So you only end up getting the positive reals as outputs. So there are a bunch of things in the codomain, all of these negative real numbers, that never get achieved. The negative reals, and the fact that they don't get achieved, the problem with that is, for there to be an inverse, not only does everything in the domain need to map to something in the codomain, but everything in the codomain needs to map to things in the domain. But the negative reals don't have anything that they link back to. Negative reals don't get mapped to anything. But they need to in order for me to have an inverse. So I'll put a sad face here. That's why conceptually this doesn't work.